Okay, the fixed point, oh gosh, sorry, try that again. The fixed point iteration method uses the iterative formula xn plus 1 equals g of xn with a given starting value of x subscript 0. Sometimes it's x subscript 1, but generally it should be 0. An iterative formula is where you get a value that comes out, and then the value that comes out you put back in, and then you get a new value that comes out, and then you put that one back in, and so you just loop around. And then as you loop around that iterative formula, you get closer and closer and closer to the root. I'll show you how this works graphically as well, but just don't worry about that for now. So going back to the example I did in my last video, where we had rearranged to get x equals 4 minus 1 over x. So g of x equaled 4 minus 1 over x, and you looked at the graphs and saw where it intersected with y equals x. So that is how this formula has come about. So xn plus 1 equals g of xn, so I've just put xn in place of x into g of x. But I'll show you it graphically, so just to give you a bit more understanding in a video or two's time. So what you do, basically the value of n goes up by 1 each time. So to find the next value, x1, you do 4 minus 1 over x0, and x0 is 3. So it's 4 minus 1 over the one before. So that's 4 minus 1 over 3. I'm going to work in decimals because actually this topic kind of lends itself to decimals. We're just getting as close as we can to that root. I think this one here, your calculator kind of kicks out some quite nice fractions. But so 3.66666. And then the next value along is 4 minus 1 over the one before. So x2 is 4 minus 1 over x1. So you do 4 minus 1 over this one here, 3.666 recurring. And that gives you 3.72727. And so you're sort of building up a series of numbers that are getting closer and closer to the root. Not all starting values will work, so sometimes it will diverge, and not all rearrangements will work, but the questions are kind. They won't give you a starting value that won't work to find a root. So you don't have to go into too much detail. I used to do coursework on this, and we used to have to go into loads of detail, but you don't need to. So it's 4 minus 1 over 3.72727, and that gives you 3.73170, and then you can repeat it again. So now I'd be doing 4 minus 1 over the third value, and you get 3.73203. So it's starting to settle down, and then you can just keep going. I'd say at this point here, it's looking like it's going to be 3.73 to 2 decimal places. You could do a little change of sign either side of that to prove that it is. So you could do 3.725, 3.735 shows a change of sign, and that would prove your result to 2 decimal places. The way to do this though really is to use a calculator. So this gets quite laborious, especially with a more complicated function. So I'm going to attempt to show you how to use your calculator on here. Hoping it will work. So using a calculator. So you can basically use the answer button on your calculator. So if we pick up the one before to start with, and then I'll show you another one as well. So I need to put that starting value of 3 into my calculator. Can you see what I'm doing? Hopefully. And so the way you do that is you press 3 and then equals. So my calculator has now stored that as the answer. And then to get the next value, you do 4 minus 1 over answer and press equals. So that's 11 over 3, which is the 3.66666. And then you don't actually need to keep putting it in. It will just keep on putting this into that answer. So if I press equals again, that's going to give me x2 as 3.72727. If I press equals again, I get x3 as 3.731707, etc. Equals again 3.73202, and then you can just keep going. And this kind of really just demonstrates these iterative formulas, and you can just get as close as you want to that root by repeating the formula. It's not changing now because the change is too far along. So that one actually hones into the root quite quickly. So if I just do one more, xn plus 1 equals the square root of xn cubed minus 2xn. I've kept my examples the same as your book, so you're welcome to have a look in your book as well, over 3, where the starting value is 1.5. So same thing, you do 1.5, press equals, that's stored it there, and then the next one along is x1. So I can literally on my calculator just do square root. You can put quite a complicated thing in here, that's what I'm trying to show you really. So answer cubed minus 2 times answer plus 5 divided by 3. And then the next value along is 1.3385. And as long as you've, just be careful that you put it into your calculator correctly. Next value along, I know you probably can't see my screen, but hopefully you see what I'm doing on the calculator, is 1.254. Next value along, so I just press equals again, is 1.2200. And then, I mean, a question will tell you how many values to do, but that's going to 1.2077 after that. So, you know, it's definitely settling on 1.2, but you could just keep pressing equals. Keep going until you get as close as you want to that root. So these numerical methods are quite powerful, especially when you don't have an algebraic method that works, and they can get you into these values relatively quickly.